Okay, so let's start. Today we will be talking about applied machine learning, that is beyond sentiment analysis, and we are going to talk about how you can build real-time object detection solutions. The There are a couple of friends with PyTorch and Python skills showcasing their skills with all of this object detection modeling. And we are going to see how you can do this without going to that stack and using ML.NET. A little bit of introduction of myself. So I am Arafat Tehsin. I am based in Sydney and I am also a Microsoft MVP for AI and I work for EY. If you happen to be in Sydney, then and you are enthusiastic about clouds, so do join Azure Sydney user group. We will be hosting another meetup virtually, so you can come in and you can join our LinkedIn group or meetup group. If you are interested in one of the if you are one of the bot developers and you are interested in sharing your skills with other developers, we have got a bot builder community, so you can come in, join that. And if you are just an enthusiastic about what and generally what conversational AI is, connect with me. I can explain you what that is, and then we can chat more about it. As I'm quite passionate about that space as well. I also run one of the global AI podcasts, and we cover the startups, we cover AI practitioners, enthusiasts, business owners who are building their solutions around AI, specifically within this region, so Australian and New Zealand region, and we bring up their stories and share a lot of stuff from technical perspective to general stuff. So please, you can go listen to them as well. And if you want to connect with me on LinkedIn, Twitter, wherever you want. And I write about a couple of these things, which I'm going to just talk today. Moving on, so we are going to discuss the projection of AI, why we are discussing this particular piece today, why we are not discussing something else. We will also look at the ML.NET. So if you are someone who is very, very new to .NET, or if you are someone who has a little bit of experience with .NET, but super new with machine learning, or you are a AI or machine learning practitioner, please feel free to stay. Don't move anywhere, don't go, because if you are someone who is super new with machine learning or AI, definitely I'm going to take to you from the very start to the end, and I'll tell you the basics of machine learning as well, so you don't have to worry about it if you don't know already. And so we'll cover ML.NET. What scenarios does it cover? What scenarios can it solve? What problems can it solve right now? And we will also see the one of the components of ML.NET, which is ML.NET CLI. We will see how easy it is. It's a cross-platform tool, and we will see how easy it is to build something which I've been building and I've built, and it has been used by a couple of developers. So I really want to share that as well. And in the last, we'll touch model builder. In fact, we will talk more about model builder than anything else. So, and where we will see how you can build real-time object detector yourself, and you can then show off these skills to your Python friends. So moving on, and I would like to start my whole discussion with this quote of Satya, and this shows the democratization of AI from Microsoft's perspective. But it's not just Microsoft, if you ask me, because I've seen a lot of companies, even startups, coming up with the similar vision, which is quite good, because this is going to break through, and this is going to bring a lot of opportunities for people who are not machine learning experts or not data scientists like me. So that's why I wanted to start with this one. Now, going a little bit further and talk about why we are discussing all of this AI stuff, why not anything else. So if you look at the projection, the value which is going to be created by AI by 2030 is enormous. And if we see right now that retail is still booming today with all the AI capabilities, and it recommends you a lot of things, it suggests you so many things, it brings up the offers, very intriguing, very interesting offers which are hard to reject. And when retail is doing so many things today, travel agencies, although we were in a long lockdown, but definitely it is going to boom again, and it is going to bring up so many new opportunities with AI. So imagine that it is doing all of these stuff today, what it will do when it will reach to 2030. So the value it is going to create is enormous. And the rate of automation of machine will go from 33% to 47% by 2025. And the manual work will decrease from 67 to 53%. And these statistics are not just from a random log. These statistics are from those people who have been looking at this and who have been doing the research in these areas. So it does mean that AI or machine learning is no more just a buzzword anymore, as you know, but it is also to show you that you being a developer who has never worked on these capabilities are will be able to build some solutions around it after this talk. So, and the reason to build up all of this, to bring up all of these capabilities, and how it is going to reach to that level, how AI is going to reach to that level, cloud AI development platforms play a very big role in that. And why do they play a very big role in that? Because not everybody has got a super heavy machine to build AI models or machine learning models. So in order to reduce that whole wall of limitations, they came up with the solution that, okay, we will provide you the platform, and you can just bring up your data and your expertise to build that model, and then we will provide you all the tooling, and we will provide you all the infrastructure. So as you can see on the slide, that all the big players or the giant software giants are already leaders in this space, be it Microsoft, Google, Amazon, IBM, and there are a couple of other companies as well. As you can see, they are coming up. So it means that this is going to be the future. Now, definitely, cloud AI development platforms are cool, but they can never succeed all alone without reducing the complexity of the development or of the creations process. So how do they tackle this? Is they are now coming up with the tooling which are quite easier for not just someone who is a developer, but for someone who's not a developer at all, or who is a citizen developer, as they say, or who is someone who likes to do things with just graphical user interface. So they are bringing up low code or no code application platforms. And if we see the convergence of machine learning platform, you can easily see that the tools which are being built or which have been built or are being built are quite thorough in terms of their offerings. Azure Machine Learning Studio, Dialogflow for conversational AI like of Google. As we see, there are so many other players like Lobe, AI Builder, and so many other players. So you can see that the simplicity of this is like, you don't need to be a complex expert, someone with the complex knowledge, or someone with the expertise of any of these tools. If you have got basic knowledge of how you can build model, how you can create some some good stuff with AI, definitely these tools can come very handy. And one of the other statistics while I was reading and I was doing a little research on this, so I read that by 2023, right after 2 years, over 50% of medium to large enterprises will have adopted an low-code application platforms as one of their strategic application platforms. So the implementation of low-code application platforms will be there. And while doing the same, I was having a look at how many people are looking for no code or low code on Google. And when I had a look at it, I saw that the trending is going up. It means that people are also looking forward to that. So yeah, this is about just a bit of how where the landscape is going. Now let's talk about ML.NET. And when we see the Microsoft stack, so it covers nearly everything. And as someone who has worked on almost every tool which you see over here, I can confirm that even if you are an expert whose day job is to build machine learning models, complex models, or whose day job is just to build something very simple or consume those models, this the stack covers it all. And you don't need to be a data scientist to come up with those solutions. As you can see that there are a lot of solutions which do not even need any basic knowledge of machine learning or AI. And with minimal technical skills, you can still build your models. And if you are a developer, which you are, I hope, so these things are quite easier for you, and you can right away start from cognitive services to ML.NET to Azure ML. And every component or every product which you see over here has got a different goal, has got a different vision. So that's why they are kept quite separately. But the good part is everything can create custom models. You can consume those models in any of your applications. So since this stack was just to show you an overview, but our focus is more on the ML.NET. Now, for those who are not 100% aware of what ML.NET is, so for the friends who are new to this, I just wanted to tell you a little bit of history about it. So in 2002, Microsoft Research came up with an idea of infusing AI capabilities or machine learning capabilities into their own applications. And I think by 2011, they named that library as the learning code, which is also known as TLC. So that was used in many of their internal products and many of the products which you use today as well, like Excel. If you see the charts on the Excel, if you see the design tab on the PowerPoint, Bing ads, Windows Hello, Windows Defender, and other stuff. So these were being used at that time as well. But in 2018, Microsoft came up with an idea to give this TLC a new shape or new look, and made a little bit of .NET friendly, and then released it as a cross-platform open source tool, which is known as, or framework, which is known as ML.NET. So ML.NET is, as I said, cross-platform, so it runs on Linux and macOS, Windows. And the good part of this is it is offline first, so you don't need a cloud to train your models, except for some of the scenarios which we will discuss shortly. Now, the good part of this is it is built for .NET developers like me. My day job is revolving around C# or .NET, so that's why I love to use this rather than I go and do my hands dirty on Python. Although Python is quite powerful, but my goals are still achieved by this. So that's why if you want to build something which you or your team can utilize, or your customers can, and your customer's goal can be achieved, then why not? And since you don't need to pay anything, it's quite cool. So you may want to use this, as I said, you want to remain in .NET ecosystem, you want to train a custom model, or you want to consume a pre-trained model, which is prepared, which was created by TensorFlow or any tool that produces ONNX models. Now, you don't need any data science expertise required, as I said. So if you have got any questions in between, feel free to write them in the chat and I'll be happy to take them as we move along. So you don't feel, you don't just wait for that. And I've got some really cool stuff for you. So I'll show you in a bit. But let's talk about the possibilities with ML.NET first. So what you can do, what problems you can solve with existing ML.NET with the current version of ML.NET. So you can solve the classification problem, which is like A or B kind of problems, true or false kind of problems. Will the customer buy or not? Is the customer eligible or not? What type of transaction is this? And things like that. And regression is like how many, how much, predicting the price of fuel, forecasting, anomaly detection, where you detect an anomaly. And I've written a couple of examples along with these scenarios. And same goes for recommendation, as everybody knows about recommendation. Now, our focus is on object detection, and it is what we are going to talk today. So, but these are the possibilities which are with ML.NET, and they have got some good documentation and samples around this, and we'll also have a look at that. Now, what tools do I have? As in, how can I build this? So you have got .NET and ML.NET API, which is super cool. You can still use, you can go and use just get the package of ML.NET from NuGet and start using it. However, you can also use it on Jupyter Notebook, Code, Visual Studio. Then we have got AutoML.NET API, and this is something really cool. And it is wrapped by Model Builder and ML.NET CLI. ML.NET CLI is a terminal-based tool. As I said, it's a cross-platform tool, and Model Builder is GUI-based. And they both leverage the power of AutoML.NET API. I know that I've not explained AutoML at all right now, but you don't have to worry, and we will just jump onto that after 2 slides. So let's have a discussion on how machine learning workflow works and how machine learning works. So if you've got a data, you have to prepare that in a way that it should be good enough to build that model. Now, I cannot go into that detail right now because of the time complexity, but it is not super complex stuff. You can easily learn from basic tutorials that how to prepare your data to build something. So theoretically, you just prepare your data, feature engineer it and do a little bit of massaging and make it in a shape that it can be predicted, or it can be trained and built by the system, and then it can be produced. So the preparation of the data, then it builds, and then it generates a model, and the process of preparation from the training is known as model creation. And when you start consuming the model, you call it as model consumption process. So this was quite basic and very easy stuff, but behind the scenes, it's not that easy. So let's give it a little break. And I have a question for you, and I have got all of this cool stuff with you with me. So I can give you all of this, almost like many of them, if you give me an answer to this question. And this question is, what kind of a problem, machine learning problem, is this? And I'll start the stopwatch timer. You have got 1 minute to give me an answer. So first 3 people will definitely get these stickers. What type of a problem, what kind of a machine learning problem is this? How much is the car worth? Is it forecasting, classification, anomaly detection, regression? prediction. So prediction just means can be any prediction from classification as well. Classification, regression, and forecasting. So there are so many predictions. Okay, that's right. No problem at all. So our time is over. That's okay. So the correct answer is it's regression problem because you are finding how much or how many. So if you are finding out how much or how many type of problems, these are called the regression problems. Daman, you can connect with me after this, please, and I'll sort out your swag pack. But don't worry if you have not got. So Tommy, Jasmeet, Nicholas, I'm sure you have got something more coming up. So don't worry. Now let's talk about the machine learning stuff as we were talking. So now we have to predict how much is this car worth. How can we do this? Usually, so what we do is as I said, that we define some features. So as we are finding out the car, so what are the features which you would like to use, which you would like to assess your car on? And definitely they are mileage, they are car brand, year of make, and then you choose some algorithms because it's a regression problem. So you should know that what kind of a regression algorithm should I use? And there are so many regression problem algorithms. So you chose the first one, and then you define some parameters around this, and it generated 30% of the model. Now, nobody wanted to use 30% of the model, right? So 30% accurate model. So how you will improve it, you just go back again and you are reiterate and include some more features, try some other algorithm, produces another result, 50%. Now you keep doing it, doing it until you reach to the satisfactory accuracy. But wouldn't it have been better if machine had done this automatically? So this is where we bring in auto ML, and what it is doing, it takes input from you and you define some goals and apply some constraints. And what does it do? It tests intelligently, automatically, and then when it sees that one of the highest accuracy model has been produced, it just takes it out and produce it as a model. So this is as simple as that. Now, definitely, we don't need to be a data scientist to use this capability because it is all good. The previous one, which I showed you, where we were tweaking, doing a little bit of here and there stuff, also, it can be done by a novice developer who is just not a machine learning expert like me. But this is much better because you don't need to know about underlying what is going on, underlying technology. But it is not that, it is not transparent, and we'll see it is quite transparent. Now let's have a look at the ML.NET CLI before we get into that stuff. And I'll quickly jump onto this. That CLI is cross-platform, as I said. It is super lightweight. You can have a lot of you can still solve a lot of problems by just using CLI, and we'll have a look at it. And I've created something called sentiment analyzer. So if you are a developer and you can you are C# developer, you can still go today and download the NuGet package, which has been used by more than 10,000 developers. And I created by writing the single command, as you see on your screen. But my data set was a little bit improved than this one. However, it is going to be similar command, and I built this. So it is also open source. I'll share the source code with you where it is relocated and everything. And the good part of ML.NET CLI is it generates the code for training and consumption, so that, as I said, that it is quite transparent. It lets you know and see what it is doing behind the scenes. Without any delay, let's have a look at the demo. So this is my terminal, but before going into the terminal part, let's have a look at this stuff. So machine learning, as I said, .NET machine learning, it is an open source, so you can go over here, and they have got some really cool samples repo as well. You can come here and you can read about all of these samples. If you would like to know more about it, these these are the best sources for you to learn about ML.NET. However, as we are talking about ML.NET CLI, so all you need to do is you need to come over here, write this command and install it. So as I have got, sorry, as I've got my already my ML.NET is already installed. So you can see that over here that my ML.NET is installed. And if I write just help, so you can see that it can solve classification problem, regression, recommendation, and MES classification by just using CLI. Now, I have got a data set over here in my AutoML folder, and you can see that it is called yelp.label. So I'll just quickly bring in that file for you so that you can see that what is this. So this is the file, and what it has, that it has just the reviews of something, and then reviews of some restaurants or some service, and then it has got a label which is an answer, which is a sentiment, you can say. So 1 as positive sentiment, 0 as negative sentiment. So we have to train this, and we have to build a new analyzer, how you can build the sentiment analyzer, which I have built. So for this, you just have to have one command, and this is the command which I have already written, and I can explain you. So ML.NET classification is the problem. My data set is this. My label column, this is the label column as I've shown you. So this is the label column. This is the one which I'm going to predict in future. And then it doesn't have any header. My training time is 10 seconds. Then if I start running it, then what it is doing behind the scenes, it is running. And for 10 seconds, it will run, and then it will produce out something which I would like to show over here. So this has been just created as sample classification, you can see. So this has been created as a sample classification model, and in that sample classification, you can see that it has generated the whole code. Now, if we try to open it up on my Visual Studio, I will show you that this is the whole code it has generated, and this is what it has been doing behind the scenes. So you can see that it is quite transparent where it comes to consumption of it, and this is how you can predict, you can consume it. And if I run, so this was one of the first utterance of the file. It has just it has brought up over here. However, if we want to change it, and if we want to write our own sentiment, we can still do that. And I say that I love NDC Sydney, and if I run it, so this is being run over here, and it will say I love NDC Sydney, and it is giving me a value of 1, which is positive, and the scores as well. So what it is doing, it is my sample data is being input over here, and then the output is, you can see it gives me a prediction, like prediction label, which is 1 or 2, and 1 or 0, and the score is like the probability of having 1 or the probability of having 0. So this is super cool. You can still use it today, and that's how I have built my sentiment analyzer. Now, as I said in my talk's title, that sentiment analysis is not the end of the world, because there are people like me who used to work with sentiment analysis, and then we just used to sit down and say, oh yeah, we have achieved something in machine learning. But this is not true, because there's so much beyond that. And one of the things is object detection. And we are going to see what you can do with object detection. So we are going to explore something more, which is called ML.NET Model Builder. Now, Model Builder is another, as I said earlier, that it is one of the tools to build your models with graphical user interface, as you can see in one of the animations. And they have been improving it. So the product team has been working hard to improve it, and they have brought in so many great changes these days that now you can easily build that model, utilize this. You can utilize the local resources, even the cloud resources, and we are going to see in the demo when we discuss that. So it can, as you can see over here, that it's a no code way to build custom models. So you don't need to write a code, but still you can access that once your model is built. So it is quite transparent in terms of what it is doing behind the scenes. It also have a MB config file, which is kind of a project file. So you can keep it for the later use as well. And it utilizes Azure machine learning experiments when it has to, because you cannot you cannot train a lot of models locally, which requires heavy duty perform operations. Now, little bit of it before we get into the demo. So the object detection is a computer vision problem, just like image classification. And on the left hand side, you see an image where an image is classified as a person. Image is classifying a person. However, on the right side, you see there is an image which has got people in it, and it has got so many like footwear, person, laptop, plant. So it is trying to locate objects within that image or frames. So this is all about object detection. Now, as I said, that model builder um, addresses all kind of common cases, but we are going to focus on object detection. Now, before we get into this, object detection, cool, everything is cool, but how will you detect, or how will you tag your object? So and this has been a challenge, because when you can't tag it, you cannot detect it. So in order to achieve this, there is a tool called Visual Object Tagging Tool. This was developed by commercial software engineering team of Microsoft. And this is so good. It is open source. It's on Git. You can go GitHub and you can check out the web version of it as well and download the local version of it. So I've got a local version of it because I like to keep my images locally. I cannot upload so many images, and that's why I would love to use that. But this is super cool, and we're going to see. So now let's talk about demo for next remaining time, and I'll talk about everything before we end it. Okay, so I will just close this and this, and we will go first of all create a simple project. So I will create a simple console app project, right? I will say, let's say console app NDC Sydney. Right? And we will just keep everything by default. So nothing fancy. And this is the project which you see on your screen. Now over here, as an extension, I have got ML.NET Model Builder. When you install Visual Studio 2022, you will get that. And I'm using Visual Studio 2022. So that's why I already have it. So if I go and add, I will see machine learning model, and I will click on this, right? I can name this file if I want, but I'm going to leave it right now. And when I see over here, so as there is a little disclaimer, this is still, Visual Studio is still in preview, and so is Model Builder. So that's why you see missing images, but that's okay. There were images over here, but that's okay. When I recorded my demo before this, they had images, but today, this morning, I saw it was not, but it is okay. It works fine. And now I've clicked my object detection scenario, as you see, because there were so many other scenarios. And if I go back, there is data classification, value prediction, and you can see that some of the models can be trained just locally. However, object detection can't be trained locally, and because it uses Azure ML experiments for now. So I will set up my workspace, and in order to do this, I will have to choose my stuff, and I will say NDC NDC Sydney object, right? And I will create an experiment. So it is going to create an experiment on my Azure. So I'll go next, right? Now I have to upload my file. And I know that you are not aware of this file. We will get into this, but first we have to train it because it will take a lot of time. So I'll just go over here. My desktop has got a model builder and this is something called target swag, my file. So as you see my angry face over here, I'm trying to detect all of these stickers which I've been showing you, like so many of them. So all of these stickers. So these coasters as well. So as you can see, these are the some of the files which I've tagged images. Now I'll go next and I'll start training. Right now, as you can see that it is starting training. What it will do, it will generate a URL, and when it generates a URL, it takes you to Azure. So you can see that it has taken to Azure, and this is the experiment which is being run, and it has not been started yet. So what we will do is we will just refresh it, and it has been started. And as you can see that this experiment is a part of NDC object detection. So it is running now. Since it is running and everything is good, it is going to take its time. So now let's go back again, one step back, and we will talk about the tagging part, the file which I have shown you. So this is the visual object tagging tool, and just to give you a little bit of more idea that, by the way, this is the sentiment analyzer GitHub repo, which we will talk about at the end. However, this is visual object tagging tool. So as you can see, you can go and download it over from here. I've downloaded it and it is working locally. So this is the object tagging tool. Now, in order to run this, first you have to have a connection. So I will say source flowers, and my provider is my local system, and over here my source flowers is my data folder, and then I will try to create another one. So target flowers, and over here I will do this again. I will choose the target folder as in target flowers, right? And these are done. So I'll go back here and I will bring up a couple of things. Okay. So now I will click on new project, because why I created those source connection and target connection, because they were required over here. And please feel free to ask any questions in between if you feel like. But I am just defining them, and I will write NDC Sydney flower, and yeah, I'll just use this token. So our flowers have got a couple of other tags. So let's say rose, daisy, tulip, and one more tag which we will add in the project. So I'll just save it, and as soon as I save it, the data folder had some target source flower, so some images, and those images were fetched over here. Now you can start tagging them. So I just tag it like this, right? Rose, so it is rose. Let's say these are roses, so you can just come over here, rose, and things like that. And let's say if you want to add new tag which is not here, called sunflower, so then you can come over here and tag sunflowers as well, and all of that, right? So you do this for all of your project, and it's a tedious task, but this is how you have to do it automatically. It cannot be done automatically. So once you are done with all of these, you just export the project. And once you are done with the exporting of the project, you go to your target folder. So target is target flowers. And over here, you can see that if I change my view, you can see that these were the images which we tagged, and this was the JSON file which was provided to our Visual Studio. So this is quite cool and easy. And this is the file which I provided it. The reason why I did not do this upfront, because it takes time to learn it, to train it. So I wanted it to train, but I can show you one of the projects which we are going to see today is this project. So I created all of this swag detector, and you can see that I did this with my all of my images, right? And this is how I tagged it. Some of them I left it like this clippy. I forgot. And yeah, so and I had some good amount of images, so that's why I tagged them, and these were my tags. So, and I exported it, and that's why you see all of that in JSON file. So how long does it take? It takes a little while. How long? Roughly about 15 to 20 minutes. But sometimes if you are lucky, you get the response within 10 minutes. And most of the time I'm unlucky. So that's why I may not see this, but that is okay. If we don't get the model back, we still have that model ready. So I can show you, and I can then export that for the later use as well when it is ready. So as I said, that we would be working, and we would be, so what it does actually, it downloads an Onyx file. So there is a file called, there is a model which is a type of, which is built on Onyx runtime. So that file will be downloaded as Onyx file. And I have already created a demo project, which is like, which is going to detect our our images. So this is the Onyx file, and this is what it gets downloaded by Azure Machine Learning Studio. And once you download that file, once it is downloaded, that file over here, you just export it to your any of your .NET application or UWP application. And the good part is there is a tool called MLGen. So there is a tool called MLGen. So this tool is basically the automatic code generation of your machine learning model. And what it does, that it creates a class file automatically like this. It creates a class file, but this, as you can see, this file was automatically generated by machine learning code generator, but this is right now, it is not available for 2022 Visual Studio. This was generated by 2019. I brought it over here, did a little bit of changes, because the file which you see is like this. So you don't have that bounding box code which I have brought in. You can only see this code which gets generated. But with a little bit of tweaking here and there and a little bit of research, I was managed to bring in this file. Now we will run this, and what it is doing, it is just using the camera feed to run it. So if we will see one more time, if our model is trained. Okay, it has not been trained, it is still being trained. So what we will do is we will try to give just one more minute. And there is another quick question for you. So if I ask you to explain machine learning to a 5-year-old, how would you do that? Very quickly, you have to tell me, and we have got like 1 minute. Come on. Machine learning for a 5-year-old, all the answers are accepted. No? Come on. That's okay. Magic. Magic. Just me, you get that. You win this. Definitely. I will. Yeah, it was definitely not magic, but I like this. So I'll surely hand over you the swag pack. Anyway, so we will try to run this now in this file, and I will switch off my camera because my camera is going to get used by this. So let me just bring in a way to how can I switch off my camera? What was the answer? There was no answer. Like I just wanted to know your thoughts, but you won it. So how can I how can I switch off my camera? Don't see this. Okay, so there you go. So what I will do is I will switch off my camera, and if you don't see my screen or something, please let me know in the chat. And now I'm going to run this. So as soon as I run this, you will see an application with me, right? So now it has also started detecting my t-shirt. And if I say this, so you can see that it is trying to detect, but it is trying to detect something which is called .NET, right? Now, if I bring in over here, so that it does not start detecting my t-shirt, but it is also detecting Azure functions, let's say global AI community, because these were my data set, right? So, and then the reason if you see a little lag behind this is because of the way I've built this. Definitely not one of the best code, but it works and it detects in real time. So you can also see the probability of it. So I think that's my last one. It has started. It started. All right, no problem. So yeah, it works quite okay-ish. And I will start my video again so that I I hope I don't see any of the window, but I'm hoping that you guys can see me. So this is the model stuff what we have shown you, but I'm just still waiting. And if it downloads, then what happens? What you do is you just bring in your file, and you can bring in over here to the ML dashboard. So this is one of the tools built by also Windows machine learning team. And what you can do is you just have to change your input type in order to run model as what I've shown you with the camera feed to pass on image. And the code is quite simple. So this is doing nothing but capturing the camera feed and then passing it to the class to detect. So where am I doing it? I am doing it over here. So it is just trying to get the camera feed. I'm just sending that video frame to my method, and it is getting it, and then I'm just showing it on my UWP app as a thread, as a UI thread. So this is what I'm doing right now. But the good part is as soon as it gets trained, then so it is now downloading, as you can see. So it is now downloading the model, as you can see that it has downloaded ML model 1.onyx. Now in order to check this, the goodness of this is this part. So the accuracy of this model is 97%, which is cool. It used underlying algorithms, which is not shown over here, which one is used, but Now, what they have done, if you go to the next step, you have got browse option. So if I come over here and if I try to detect this, it will try to detect is it .NET or Azure function, and you can see that it has quite rightly detected it because of the light conditions as well. It depends, so that's why my t-shirts way was quite similar to the global AI one. I think that's why it was trying to detect the similar one. But yeah, you can improve it. You can put up some checks on the scores as well. Now, if I go next, it also gives me the capability to add this code to my solution. And this is not just the console file. You can also consume it as a web API file, which I am trying to add over here. So you can see that how easily it gives you all of the code to bring in over here, and it should work fine, right? And this code is already there, so you don't have to write anything. Consumption and everything is already present, and you can keep this file for your later use. Just a quick one before we wrap up. So I will show you that how you can, so your file is this, right? Your file has been your file, this was your model. So if I create this, open this model over here, it will be opening up in the very big graph, and that graph will definitely has a lot of information which you may not understand, which I may not understand as well. So it has got so many other stuff going on, and this is how your machine learning models look like, by the way. So over here, you just have to come and choose it as an image, right? And then you just save your model as save as. So I'll just save it as save as dash NDC. And as soon as I do that, my model is being saved. And when it is being saved, what I will do is I will go over here and try to add this model. So if I quickly bring in my models folder, which is okay, which is this. So this is my model folder, and this is my NDC Onyx model. So I have brought in here, and I will just change its copy always, or copy if newer, whatever you like. And then that's the name of it. I will come here where it is being used. And if I switch my video off just for one last minute again, and I'll try to run this model. And now it is going to run because my video is off. So you can see that now it is trying to detect. Now it is using the same new model, not the one which I have shown you. So as you can see that it works quite good. The new model works as well. So that's about it from my end. The only thing which I would like to share with you is these resources. If you don't, even you don't have to take a screenshot or something, I will put up this on my repo very shortly. And in addition to this, we have got some great news from the friends of Microsoft. They have given you a chance to win this as your pass of $100. So you can copy this URL, claim this. In addition to this, you have got swag to claim. In addition to my swag, you will get this swag, big swag as well. And unfortunately, if you are outside of Australia and New Zealand, we cannot ship it, or Microsoft cannot ship it. And if you are the one who's being missed out because of this, connect with me. I'll try to find out a way, not for the Microsoft ones, but we'll have a chat on how we can send you mine. So that is it from my end. And if you have got any questions, the floor is open for you.